Remote queue. So what is a remote queue? Let us say there is a bank and its headquarters is in some other place, and there are multiple branches, and each branch has its own queue, and the head office has its own queue for various uh, applications, right? So out of all those applications, loan processing application. So remote queue, before we understand what is in this architecture, in this uh, workflow diagram, let us understand what is the purpose of a remote queue, why it is used, in what scenarios it is used. So basically, a remote queue in IBM MQ it is not a container of messages like a local queue. It is just a definition, or we can call it a pointer that tells your local queue manager where to send, where to transmit the messages. Exists only in the local queue manager. It does not actually hold any messages, but instead it contains the target queue manager's details. This remote queue, it contains the details of the target, so which is head office. So queue manager HQ and loans request queue. These two details are stored in the remote queue. It basically points to the target queue manager. And the requests or the messages are sent to the transmission queue. So what is a transmission queue? If you want to send messages to any remote or third-party queue manager, which is uh, available on some other location or some other region or some other environment on a separate MQ server, then you will use XMIT queue or transmission queue. So this is XMIT queue. So here you see it points to QM HQ queue manager and loan request queue local queue, which is local to the remote queue manager QM HQ. So these details are configured in the remote queue. When the application sends the messages, the application will connect to the queue manager, and the messages are sent to the remote queue, and the remote queue sends those messages to the XMIT queue, and the transmission queue will deliver it to the queue manager HQ. As we know, remote queue does not store any messages like local queue. A remote queue immediately routes the messages to a transmission queue as soon as the application puts the messages, sends the messages to the queue manager. So messages will only be temporarily stored in the transmission queue. If the remote queue manager is unavailable, or the communication or the channel or the network channel is down. So the transmission queue stores the messages only on a temporary basis. In what cases? If the remote queue manager is unavailable, or if the communication link is down. So the remote queue itself never directly holds any messages. So whenever it receives the message, it will send it to the transmission queue, and the transmission queue will transmit the messages to the target queue manager. So how the messages are routed? There are two queue managers, queue manager 1 and queue manager 2. So order service application, it puts the messages in the remote queue. Remote queue will send it to the transmission queue, and transmission queue uses the sender channel over and sender channel to transmit the messages over TCP IP to queue manager 2. At the queue manager 2, there will be a receiver channel that is open to receive the inbound communication, right? So once it receives the messages, the inbound communication, the messages are stored in the local queue of the queue manager 2. And the payment processor application will consume the messages from the local queue, which is payment queue. So here you see there are the internal MQ objects or internal objects of a queue manager on both the ends are different. The sender has a remote queue and transmission queue and sender channel in order to send the messages to a remote queue manager. So at the receiver's end, there is a receiver channel and local queue where the messages are stored until the payment processor application consumes it. But remote queue, it does not store any messages. As soon as the order service application sends messages, remote queue contains the queue manager 2 details, the local queue details and the queue manager details. So it will send the messages to the transmission queue, and the transmission queue is responsible to send or route the messages over sender channel to receiver channel. So this is how the communication between two queue managers work. And the internal components are also based on the type of queue manager. So this is the QM1 is the sender and QM2 is the receiver. So to understand the workflow here in detail, we can see I have drawn a blue line here. So on the left side, this is a sender or producer application. On the right side, this is a remote queue manager or consumer application. So both the queue managers are hosted on two different MQ servers, maybe on two different environments, right? So order application QM1, it puts the message in the remote queue, and this remote queue contains the details to payment queue. So this is a payment queue, which is on the other side. So it contains the information of the remote queue. These all like the queue manager, remote queue manager name, and the local queue manager, local queue name. So as soon as the remote queue receives the messages, it routes to transmission queue. The sender channel will pick up that message and it will send it to the receiver channel, to the remote queue manager via TCP IP. So at the receiver's end, the receiver channel will be open to accept the inbound communication and it will deliver to the local queue. So the payment application on queue manager 2, it will get the messages and the payment request will be processed by the payment application. So this is a workflow and the usage of remote queue. In what scenarios? When sender and receiver applications are running on different MQ servers or different queue managers. And when you're integrating applications across data centers or cloud environments, and if you want load distribution when messages need to be sent to multiple remote systems. So these are the scenarios where you can use remote queues. That would be all. We'll see you in the next lecture.